All right, so that is me. My name is Chris Crocco. I am a sales engineer, not a site reliability engineer, here at Splunk. And today we're going to talk about how to use ITSI, VictorOps, and Phantom for site reliability engineering, and talk a little bit about site reliability engineering in general. So forward-looking statement, I'm sure everybody's seen this 800,000 times so far this week. Just so you know, we may say some stuff that may change in the future. That's all that means. So before we get into how to use all of the tools that we're talking about today for site reliability engineering, I wanted to take some time to talk about site reliability engineering itself. I have a lot of customers that I'm working with that are SREs or have SREs, and the reason that they have it is their boss heard this cool new thing called SRE, and they told them to do the thing, right? So let's talk about what it is, what it isn't, and what you should expect as you go down that road for site reliability engineering. So site reliability engineering is, at its highest level, a set of core tenets that are designed to allow teams to ensure that day-to-day operations requirements are met while minimizing the amount of operations work that's needed and keeping the focus on engineering tasks. It's meant to ensure that you're not getting dedicated resources for operations in those SRE teams. They still have a focus on engineering. They're still engineers and developers, but it's really maximizing efficiency, automation, and reducing the amount of time that they're spending doing operational tasks. It's also meant to increase the pace of innovation and velocity. So a lot of traditional change management is also taken into consideration with SRE. And it's a little bit different for everybody, right? Just like DevOps and Agile and everything else, there's not a book that says thou shalt SRE, right? The way that we do SRE at Splunk and the way that they do SRE at Google and the way that you do SRE at your company are all probably going to be a little bit different based on your company's size and your needs and everything else. So site reliability engineering should not be a catch-all for the dev team's deployment work. Your SREs are not your deployment team. They should be checking stuff. They shouldn't be doing the dev team's work for them. They shouldn't be a strictly operational mindset. So even though they're engineers and they're doing engineering work, they shouldn't be engineering with operations as the forefront of that. A single point of contact for all teams. So if you have a NOC and you rebrand it SRE, that's not SRE. That's slapping a sticker on something that you're trying to make go away. So don't make them a catch-all for everybody. Make them strategic. They're also not in charge of DevOps teams' priorities, which means that they're not dictating what the backlog should look like. They're not dictating what bug fixes should look like. They're not dictating, what a scoring session should include. Any of that stuff is still within the realm of the DevOps team. And again, not a by-the-book organization. So this is something that I see in a lot of the customers that I support today, where they have a charter for site reliability engineering and everybody has to follow these very rigid guidelines. And that's kind of defeating the purpose of it. So don't make it a rigid, static thing. So who should be a site reliability engineer? A lot of times when folks are making this transition from a traditional operations model to an SRE team, inevitably what that means is that you're going to decommission your NOC, right? And decommission your technical operations and ops engineering's teams. And that's okay, right? What you need to do is take a look at your very high-performing resources on those teams, the people who are your go-to people that have a wealth of operational knowledge, that also have an aptitude and an interest in learning how to develop and engineer. Problem solvers, so the people that are actively looking for things to improve, people who are always finding a better way to do things, that's always a good quality to have. Curious and creative, so if you have somebody who you always find them digging through CentOS boxes and looking at code and, just proactively figuring out what's going on. That's also a great asset to have in site reliability engineering because it helps you find problems. And then self-directed and team-focused. And what that means is everybody on the team wants to be on the team. They want to go out and find things and proactively help the organization, but they don't need it dictated to them, right? So it's team-focused, but everybody on the team knows what they need and should be doing. So SRE and DevOps, a lot of people kind of think of them as interchangeable or the same thing, or they're not sure where the difference is. So the difference between the two, this is how a lot of people think DevOps and SRE work together. And I've seen this in a lot of the customers I support as well, where SRE says, hey, I found a thing and you're doing it wrong. Make this change. And then the DevOps team says, whatever, man, my code's good. I know my stuff works. Buzz off. And so if you create that conflict between your SREs and your DevOps resources, you're not really getting the benefit of having an SRE team. So really the better way to think of it is instead of being dictatorial, it needs to be collaborative, like this, right? Hopefully a little bit less, blood splatter on the walls. But what it needs to be is, I'm the SRE, I found something that I think is important for you to know about and fix. And then your DevOps resources can take that and say, thank you for the information, thank you for sharing what you found and collaborating with us. We're going to take that back, look at our backlog, look at our bug fixes, look at our priorities, and help inform our decisions based on what the SREs have provided to us. So really, really important to make sure that it's a collaborative experience between your SRE teams and your DevOps teams. So I mentioned before the tenets of SRE. So let's talk about that really quickly, and then we'll talk about how you actually apply all of the bells and whistles to make that happen. So the core tenets of SRE are right here on the screen: monitoring, emergency response, change management, maximizing velocity, capacity planning, efficiency and performance, and finally focus on engineering. Now, a lot of this is, it all sounds nice, but to contextualize it, particularly if you're making that transition from a traditional operations model to a new DevOps and SRE focus model, is to show where it used to be and where it is now. So monitoring and emergency response, that's your traditional NOC and your traditional operations team, right? Your people that are staring at screens, responding to problems, making sure that things are up and running. Change management and velocity, that's your traditional change management team. So if you have a team that looks at a deployment schedule every week or every month, who manages a Jenkins pipeline and executes code, or manages SLAs for these things, that's also now something that you can internalize into your SRE responsibilities. Capacity planning and efficiency and performance. This is making sure that you are really cognizant of what's in your environment, what can scale in your environment, what can your environment handle right now, what can your deployment pipeline handle right now without causing conflicts or failures, and then making sure that you're finding areas where you can constantly improve and scale out and build more performance that then impacts that velocity. And again, all of this stuff is designed so that you can keep the focus on engineering. You want your people who are building things, making changes, innovating, focused on that, and not so much focused on putting out fires. So let's talk about where those tenets fit in the Splunk ecosystem. So the first thing that we're going to talk about is ITSI. You're going to use that for monitoring, capacity planning, alerting, and some of the efficiency and performance measurements that you need. If you have alerts, and we'll talk a little bit about the difference between monitoring and alerting, and you need to get hands on keyboards, that's when VictorOps gets in. To make sure that you're doing targeted emergency response, focusing on engineering, and then change management as well. And then lastly, Phantom is for those known conditions in emergency response, as well as that focus on engineering. So again, we'll talk about this all more in just a moment. So first, let's talk about making monitoring matter. And the first thing that I want to go over is, again, going from that traditional monitoring approach to the SRE monitoring approach, you have to be very cognizant of what the differences are between the two. So in a traditional monitoring approach, you wait for specific conditions, to occur. There's not a lot of correlation between those conditions. They remain very disparate in, an alert queue, something like that. Interpretation of those alerts, interpretation of monitoring is all done by a human being. People are determining what is and is not important and what requires human attention. You usually have dedicated people for taking action on conditions. Again, traditional NOCs, traditional technical operations, traditional IT operations teams. Manual ticketing and logging of events, so all of the administrative tasks are done manually by a human being. And then siloed root cause analysis and problem resolution, which means once that traditional operations team triages the issue, they may throw the ticket over to a dev team and it goes into a black hole. There's no communication on that. The difference here, when you're moving to monitoring and SRE, is automation of the interpretation and correlation of issues, which means finding what has relationships to other events in your environment, whether those events are notable or not, and what the level of severity is. Humans are only engaged when manual action is required. So in monitoring, you have passive consumption of information for efficiency and performance. It's looking at dashboards, generating reports. You should only really get human beings actively involved in reacting to things if something requires intervention and can't be fixed manually or automatically. Ticketing, logging, and alert tuning is also automated. So you want to reduce the amount of time that people are pivoting from fixing a problem to documenting and sharing information. You also need to know your neighbor-independent services, and those are intelligently aligned. You need to know if what you're seeing is a symptom or a cause. And symptom events are informed only if self-recovery doesn't occur. So if you have a deployment going out, you know that something's going to break for a little bit, but you expect it to self-recover, that's fine. You don't need to let anybody know unless that self-recovery doesn't happen. So monitoring services in ITSI, there are three key components that you need to have for a successful ITSI service. The first one, the very foundation, is KPIs. And that's the measurements that you have for your service. You have entities, which are the objects that are generating those KPIs. And then you have that nearest neighbor, so whoever can be influencing your service as well. So the first thing that you need to do in order to get those KPIs is to decompose your service. Has anybody ever done a service decomp in the room? A couple of people? Did anybody find KPIs that you didn't think you needed before you went into the service decomp? Did anybody find a way to measure those KPIs that was different than what you expected? It's hugely important because if you don't know what those KPIs are, you also don't know what healthy means. That's the next thing, right? So when you're monitoring, monitor for healthy first. Know what good looks like first. And then know who your neighbors are. So I'll show this in a little bit, but you need to, if you're running an app stack, you need to know where your infrastructure is. You don't need to know all the details, but you need to know where your infrastructure is and whether that will impact you or not. And then you need to tie all of those together into a single ITSI service. So the way that you do that, and the reason that this is important, is so that you know whether you need to take action or not, whether it's informational or actionable. So in this particular situation, you can see we've got a couple of those little exclamation points that mean that there was a notable event on an entity. And I can see that my service and my neighbor's service were impacted by a notable event on somebody else's infrastructure, right? This is really, really important because if I'm that first service right there, I know that I don't need to spin up my laptop, get into AWS, start troubleshooting things. I just need to talk to the DBAs and say, let me know when it's fixed so I can know when my service recovers. The other thing that you can do, and again, this is pivoting from monitoring, which is consuming information and not necessarily acting on it right away, but being informed. If your monitoring translates into alerting, if you find something by way of monitoring that requires action, you can do that in ITSI, right? So when you open up a deep dive, this is a deep dive on that same service that we were just looking at, I can see very clearly the individual KPIs that are going to denote when I'm having an impacting event based on the automated thresholding that's going on. So you grab the KPIs that matter, you find the smoking gun in those KPIs, and then you can create a multi-KPI alert on it, right? So the good thing about this is you can gather a subset of your service's information and say these are representative of a singular condition. All right, next thing, machine learning to the rescue. So getting back to the whole concept of letting automation, letting your tooling make those correlations and those interpretations for you. ITSI has a lot of these features pre-built in a way that basically gives you an easy button as an SRE. So the first thing is anomaly detection. When you're building out your services, at the bottom of your service configuration page, you can turn on anomaly detection. Right? And what anomaly detection is going to do is, even if something is normal, if the way it's behaving in normal, so if you're used to seeing a cadence and then it flatlines in normal, it's still weird, right? We need to check it out. This turns on the machine learning in the background to find anomalies. Once you've done that, you can pipe it into predictive analytics in ITSI, and then figure out when those anomalies are going to happen in the future, right? Give you an early warning system so that you can stop things before they become a problem. And then lastly, you can use smart mode in your aggregation policies to do auto clustering and correlation of those individual notable events into higher level episodes so that you're reducing the noise and you're saying this is a singular event that you need to look at made of constituent notable events. So once you've moved from monitoring to alerting, you've turned on that machine learning in ITSI so that you're getting all of the correlation, identification, severity handed to you by ITSI. The next thing to know is what you need to do with those conditions where you need hands-on keyboard, right? And that should generally be for things that are unknown. So instead of having a laundry list of alerts in an incident management system that a NOC is looking at and just working through, alerts should be rare, significant, and immediately impacting to the business. It should be a really big deal if somebody gets a notification. ITSI should have already interpreted and correlated that data, so you should be getting information on what is being impacted by whom. Unknown and complex issues should always take priority. So if it's something that you've never seen before, if it's something that you don't have a playbook for, if it's something for a brand new service or a brand new KPI that you've never had an incident for in the past, those always go to the top of your priority list because those are usually the most impactful. Triage is not the sole responsibility of the SRE or DevOps teams. So your SREs, again, are not your NOC that's been rebranded. They need to be able to detect, direct, and communicate what is going on to the appropriate resources to get it done. So in the example that we just looked at, that probably means that the DBA team needs to be engaged and they need to be empowered to reach out to the resources that need to solve the problem. And then lastly, ensure that incident administration is automated up to the RCA process. As much as is possible, you should never have somebody looking at a ServiceNow, Jira, Confluence, and making edits to it or posting updates to an outage. You should automate that. So the way that we do that, moving from ITSI to VictorOps, is through the aggregation policy. You can see here in our action rules, once we've already set up that correlation through smart mode or whatever event grouping that you're going to do for your episodes, you can configure particular action rules to say, hey, I want you to send this to VictorOps. It's going to give you a pop-up that looks like this. You're able to put in an alert ID, some state messages, a routing key if you need to, additional contextual information that may be relevant to the human being that's that's going to receive this notification. From there, over in the VictorOps side, you can set up alert rules. This was, I believe, formerly called the transmogrifier, which is a fancy-dancy way to decorate that with even more context, and then do a lot of that incident administration in terms of notifying Slack channels, going out to ServiceNow, updating incidents there, all of that incident administration. It's also how you target the correct person so that you're only getting one person or one team instead of a spray and pray email or picking up the phone and hoping you have the right person. Who's ever had that happen to them before, by the way? A couple people? Really only just a couple people? Nobody else has been on the phone for something that's not their problem? Yeah, not fun. That's what we're fixing here. So once you do that, it's going to send a notification to the designated resources that are going to respond to that issue. Again, your SRE team, your DevOps team, whoever else needs to be engaged. And they're going to get the relevant information in order to work the issue. What we're looking at here is actually the Project Fury release for VictorOps. And what it's going to allow you to do is, again, get all of that very detailed information from ITSI into somebody's hands and allow them to either collaborate with other people or fix the problem themselves. So once you've done that, once you've figured out what caused that problem that got human beings involved in the first place, you've done that root cause and that postmortem, you should be able, in most cases, to turn those manual actions that were taken into automation and orchestration. So what we mean by that, the difference between, there's a bit of a difference between automation and orchestration, and they tend to be interchangeable for a lot of people, but there's a subtle difference in that automation is a singular task or function. It's generally a relatively simple process, so creating tickets, adding a new cluster node, incident identification, posting an outage. That's what automation is. What orchestration is it's taking all of those disparate automation tasks and scheduling them in such a way that you have a full end-to-end process that is executing those automated actions, returning them, and then taking an additional action. So using Phantom for ITSI episodes, what I've done here in this example is I'm actually looking at the ITSI tracked alerts summary index, which gives you all of the information that goes into episodes. It's where everything that ag policy is generating gets stored in your environment. And what we're doing is we're creating a few new fields and we're formatting what the payload will look like in a way that Phantom can accept that and has all of the variables that it needs. So specifically, you can see I'm creating a scope, a run, a playbook ID. So I'm saying this is exactly what I want you to execute when you see this thing happen. From there, you can pass it through directly to Phantom, and I added 2 alert actions here. So you have send to Phantom, right, which is the pre-built Phantom alert action that comes with the Phantom app, or just a regular webhook. And I know there are a lot of people out there that tend to prefer one or the other, depending on whether that, you need to go through a firewall or a proxy or something like that, and you may not have direct access to your Phantom. That's when you would use a webhook, but it's the same basic process. And from there, it's going to hit a Phantom playbook and run that orchestration. Now, who's seen Phantom before? A couple people? Who's used Phantom before? One person? A couple people? So one of the things that we're trying to do with Phantom, when we originally acquired Phantom, it was a security product. And what we're trying to do is move it from a SOAR product to a general orchestration tool for anything that you need it for. Most of the Phantom team has been, or not most of the Phantom team, a lot of the Phantom team has been working on general IT operations use cases. So anything from network device configuration to DNS registrations and other things that we're seeing customers use the tool for. So I would recommend talking to the Phantom guys out in the pavilion, talk to them about Phantom for IT, because a lot of this is pre-built and ready to use. So this is kind of how all of that stuff comes together from an alerting event monitoring and reaction perspective. So the life cycle of this is going to be creating and updating alerting and ag policies for known and unknown conditions in ITSI. So that's the anomaly detection, multi-KPI alerts, ag policies, predictive analytics. That's going to send new and unknown episodes to first responders in VictorOps. Again, your first responders can be the site reliability engineering team, the DevOps teams, or anybody else that's required to resolve the problem. Once that issue's been triaged, SRE team is now responsible for RCA postmortem using ITSI and VictorOps. Both of them will give you reporting information on when the individual notable events were detected, how long it took for that to get to a human being, what the person did once they got it, and you can combine all of that into a fully packaged RCA and postmortem. That is then given to your DevOps team to document what the problem was, whether there needs to be a bug fix, whether there needs to be something significantly changed. And once they know how to solve the problem going forward in a more permanent fashion, they can take a look at the manual actions that were done by the person from the VictorOps side, turn that into a Phantom playbook, or identify assets within Phantom that are already available, that are appropriate to solve the problem, create a new playbook for this condition so that a human being doesn't have to deal with it again. So you're only, as an SRE, you should only ever be looking at unknown or complex issues or situations where that automation has failed. All right, so we've talked a lot about the monitoring and alerting piece. That's kind of the biggest bulk of what everybody's concerns are when they start down this road. But again, velocity, capacity, and staying engineering focus is also a very big component of being a site reliability engineer. And that has to do a lot with your CI/CD pipelines. And pipelines are complicated. So monitor the changes and change the monitoring. And what I mean by that is you're going to have multiple CI/CD pipelines doing multiple things with multiple services in multiple verticals of your organization, most likely. Not all pipelines are going to have the same capacity, velocity, or success rate. So you may have DevOps teams that are very mature, very aware of what their service is, and they have a really good success rate and velocity. Whereas, if you're just starting down the DevOps road, if you have a new team, a new service, a new product, that velocity is probably going to be lower. Your success rate's also going to be lower. So be accommodating for all of that to happen. There's likely to be a variety of deployment tools in use. So you're probably going to have Jenkins and/or Bamboo and/or Chef and/or Puppet and/or homegrown magic stuff that somebody's running under their desk. And you have to be able to support all of it. And you need to see what's being deployed and understand how it's impacting monitoring and learning. So if you deploy a new microservice that has new KPIs, you need to account for that in your service. You need to make new services. You need to adjust your thresholding. You need to be cognizant of how that's going to change, because if you don't, it can skew your ability to react to events. So there are a couple of different ways that we can help with monitoring the pipelines using ITSI. What we're looking at here is the ITSI module for continuous delivery. And what this does is it takes the information that comes from the Jenkins, Bamboo, Chef, and I believe one other tool, the TAs that are associated with those, it grabs those. It will effectively pre-build a set of KPIs for you. So you can see here, this is actually the Bamboo KPIs and services that you would see, the individual notable events that you would see. So this is what it's saying it recommends as a service, and you're going to get that for all of those tools. Again, it's giving you an easy button. And from there, once you say this is what I want to look at and that looks right to me, you can pump it back into ITSI so that you have your deployments, you have your success rate, you have everything that you need to be able to report on how well your pipelines are performing, where your areas for efficiency and improvement are. So now we're going to get into the weeds with some stuff. And it's okay if this looks complicated. It looks more complicated than it is. So in this flowchart, this is for making adjustments to your services in your environment using the API. So this is a situation where if you have an Ansible playbook, if you have a chef cookbook, you can use the API and create tasks that concurrently adjust your monitoring based on whatever your other deployment activity is. So what we're doing here from the top left over, we're doing a git just to see what's in ITSI, right? And what we're doing there is we're just saying, do I have services? What's in those services? We're going to do a diff against what we're planning to change. So if you're adding a KPI, if you're changing a threshold, if you're just seeing if that's already there, this is how you do that. If you have the dev, test, and prod services active, so first off, make a dev, test, and prod service. You can do all of that in the same ITSI environment without having separate clusters for each one. You just need to have them labeled appropriately so that you can move things through that pipeline process effectively. So if you have those, what you're going to do is do a post to the maintenance services endpoint for ITSI, which is going to put the services in question into maintenance mode, reducing that noise that would come from notable events. If you're making changes to thresholds and KPIs that would create erroneous notable events, this mutes that. The next thing that you're going to do is do a post to your dev service, right? So with whatever change that you're doing. So if you're making a new dev service for the first time, that's what you're going to do. If you're adding a KPI, if you're changing a threshold, do it to your dev one first. Once you've done that, you're going to do a git, make sure that the change that you put in there is looking correct. And again, you're not doing this, but your automation tasks are doing this. If it looks good, great. What you're going to do is templatize that. So templatizing, it just makes a scalable, repeatable object that you can use to apply to other services or to make new services. You're then going to post that to your test service. Again, do the same test process. Check for that to be valid. If that looks good, you're going to apply that golden image that is your service template to your prod service. And at that point, you have fidelity and parity across all three dev, test, and prod. If at any point that change validation doesn't work, you're going to send a fail message back to the playbook and say, listen, your monitoring isn't working correctly. That's, again, a situation where you can get it to a human being. They can see what's going on. So this is how you do that dev, test, and prod CI/CD pipeline adjustment. And you can take this same process and use it to do a little bit more fine-tuned adjustment. Right? So what we're doing here is we're checking for that service template, seeing if the service template is there, putting in that maintenance mode, setting up changes to the service template directly, and then deploying out. And again, same thing where if any of this fails, you're sending a fail message back to the playbook that's running all of this through the ITSI API and saying, hey, get a human being involved. All right, so I know I've been talking a lot, I've been showing a lot of conceptual stuff, but I wanted to show you guys what this actually looks like in the real world, so you know I'm not just, feeding you a line here. So let's take a look. If it'll work. There we go. All right. So, who played Boss of the Knock this year? Anybody? One person? Two people? Do you guys remember when you got a call from a CSO or a CPO saying, hey, the employee portal's broken? We're going to take a look at that service. If the HDMI cord will work. Sorry about that, guys. There we go. All right, just going to have to hold that there. All right, so this is a service that we made for Boss of the Knock this year. Where do I have a problem? Can anybody tell me? Database, right? So we can see we have a problem right here. right? And we can see exactly what the episodes were that caused this problem. Right? And again, all of this stuff is stuff that's going to be automated. I'm showing you through the episode review just so you guys can get a good understanding of what it looks like in the background. A human being, again, should never actually have to look at this piece unless there's a problem. But we can see that there's an event timeline where I can see exactly when this went critical. I can see root cause. This is all information that in my aggregation policy, I can send to a human being to say, listen, this is all of the contextual information that you need to solve this problem. So, let's send to VictorOps. Right, so whatever it is, and this is stuff that can be pre-configured again in the aggregation policy, so ITSI is kicking off all of this information without manual intervention. So once we're done with that, there we go. So that went over to, I think I actually just paged somebody right here. Did you get a notification? You got a note? What'd your notification say?
I'm scared, or it's broken and I'm scared.
It's broken and I'm scared. All right. Cordis, you're my only hope. What do we do?
We're going to have to look at the annotations.
Going to have to look at the annotations. So there's my ITSI incident. So what you're going to see if you're using VictorOps is VictorOps does a lot of noise reduction on its side as well, so you'll see a lot of alerts coming in. Those you can do a many-to-one relationship where you have a lot of alerts in one incident, and that's what's gone to a human being. So let's take a look at the annotation. James Pesto has told us to run a Phantom playbook called Last Known Good, right? This is a known condition. I can run this playbook and solve the problem. So that can be sent over here to Phantom, where I have a playbook called Last Known Good. And if we open that, you can see we have a very complex, not a very complex, but we have a somewhat complex path of resolution where we're doing some things, we're blocking IPs, we're updating whitelists, we're doing things that we need to do to make sure that the web tier can access the database again. And from there, then we can go take a look at how much load it's using, how performant our Phantom stuff is, how long it's taking to run that playbook, make it more efficient, pipe all of that back through here so that James Pesto knows that the Phantom playbook actually solved the problem, and then you can also put it back in ITSI so that things are normalized here. So, Cordis from VictorOps right here, who was kind enough to receive a notification from me. Cordis, did you actually have to look at a UI?
Just on my phone, just a notification.
All right. Did you have to actually get your hands on a keyboard to fix the issue? Nope. What did you have to do?
Acknowledge it and then run a playbook.
Acknowledge it and run a playbook. Right? That's what your SRE team should be doing anytime that they get a known condition, right? If they're going to get notified at all. And that's really what I wanted to get across to everybody today is if you tie all three of these tools together, you have an end-to-end process to let Cordis or anybody else in this room focus your time on pipeline development, writing code, working with your DevOps teams, and let all of these tools do the heavy lifting for you. All right, so I think we've got about 5 minutes left, so I'll open it up to questions. You first?
Are you seeing more, if I have all these tools, are you seeing more ITSI to VictorOps and Phantom or more ITSI to Phantom?
Good question. So the question was, are we seeing more ITSI to VictorOps to Phantom or ITSI to Phantom? And it's kind of an even split. It's actually a little bit of both. You really should be seeing more ITSI to Phantom because of those known conditions, and any time that you get something that has gone to VictorOps, it should only go there once. One of the things that you can also do in Phantom is you can put in a VictorOps module there. So these tools, it's not a linear integration, right? So VictorOps can send Phantom can send a VictorOps notification if an automation fails, right? And we also see that quite a bit as well, where we're attempting to solve the problem. The automation has failed. Now we need to get the SRE team involved. Good question. You had one right up here?
First, sometimes I see you have an annotation with a chart or URL in the VictorOps.
Mm-hmm.
How did you add that chart or URL into the annotation when you get the alert?
Oh, good question.
Second one is there any way to integrate Phantom or ITSI into Jira? So when it take any action, it will update the Jira, take care, something like that?
Great questions. Okay, so we've got a two-parter up here. First one is, how did we get those pretty charts into the VictorOps notification that we showed in that screenshot earlier? A lot of the VictorOps pre-built integrations will reach out and actually grab that information and pull it in. Excuse me. So the one that we just showed is in an upcoming release, specifically for ITSI to make sure that we're really enhancing that. The signal effects integration that we just did, I got to take a look at that today. It's really cool. It does that. So look at the pre-built integrations, and I believe that there are other ways to iframe that in effectively. The second part of that was, how do you integrate all of that with Jira, right? So there are pre-built ITSI alert actions for Atlassian products. So there's one for Confluence, there's one for Jira. There are a couple other ones. You can also make your own if you have a highly customized Jira environment. In my previous life, we had to do that, and it was, we had customized Jira, so we had to customize the solution, but there's an SDK to do that. There's also a Jira task that you can download in Phantom, so that Phantom is just creating tickets and updating things. And I believe that there's a Jira integration either on the way or already available for VictorOps. Yep. Good questions. Yep.
Earlier in your slide deck, you said that you should automate alert tuning.
Yes.
How do you automate alert tuning?
Automate alert tuning, great question. So automating alert tuning, what I mean by that is, don't have static thresholds for everything, right? So 2 a.m. and 2 p.m. usually look very different, and you don't want to be woken up at 2 a.m. for something that's, a standard condition, right? So use adaptive thresholding and anomaly detection in ITSI so that it's tuning itself and saying this is what normal looks like right now, and training those models so that it's not necessarily sending you things that are based on a static breach. Whenever you have something particularly time-based that has that variable element to it, adaptive thresholding is the best way to do that automated tuning. Great question.
I'm assuming if you have one or two of these, let's say you have ITSI, VictorOps, you can still benefit from it and do a lot of the stuff you cover, right?
I heard about half of that, I'm sorry.
We have Splunk objects, but I'm looking at getting third one.
Phantom? Mm-hmm.
And I want to do a lot of the stuff you said about SRE, but we don't have ITSI and we don't have VictorOps. You're probably not going to buy Phantom either, but that's the theory. You can still do a lot of the orchestration without the others, correct?
Yes, you can, absolutely. All three of these tools can operate independently from each other. The Phantom stuff, you can run Phantom from, CloudWatch, you can run it from core Splunk, you can run it from a lot of, you don't need to have all three in order to get the value out of it. Thought I saw another hand somewhere.
Do you apply any machine learning in this demo or process, or how you will know the moving target of all these alerts, threshold?
Oh, great question. So yes, the question was, did we apply machine learning in the demo and the Boss of the Knox stuff? And yes, we absolutely did. We used adaptive thresholding, and we specifically broke something in a particular way in a particular time so that we knew it was going to be outside of the window of normal for that time window. And that's where we got all of the database and thresholding stuff.
Is this machine learning piece built in already, or we need to?
Yes, the great question. Yes, the machine learning piece of ITSI is built into the product. There's nothing else that you have to do.
For your demo of the database metrics, were you using Splunk infrastructure or something else?
No, so those were all coming from Azure. So we were using the add-on for Microsoft Cloud Services for the blob services, and then we were sending directly to a HEC token for all of the database and web app telemetry. Great questions, guys. Any other questions? No? All right, well, I really appreciate you taking the time to listen to me today. If anybody has any other questions or thinks of anything else that they want to talk about, I'm always happy to talk after the session or if you see me at the search party. And again, I appreciate your time. Please take some time to rate the session and enjoy the search party tonight, guys. Thank you.